Welcome to Galaxy Aerospace Ghana. On today's segment, I'll be interviewing the first female to ever be in the field of astrochemistry. Please, you're welcome to today's segment.
Thank you for inviting me.
Okay, please, may we know a bit about yourself, who you are, and how you found yourself in the field of astrochemistry?
Thank you very much. I'm Dr. Naomi Asabre Frimpong. I'm a research scientist at the Ghana Space Science and Technology Institute. I'm an astronomer and also an astrochemist. I have been in this field for about 2-3 years, and I started in SHS. I did science, and then I did my BSc chemistry in the University of Cape Coast in Cape Coast, where I did my thesis in phytochemistry, which is basically using plants to test how they can kill bacteria. So that was very interesting for me. Then I did my master's in nuclear and radiochemistry, and in that thesis, in that research, I worked on water as hydrochemistry. So I worked on plants and I worked on water, and my interest has always been in chemistry. So I really wanted to stay in that field. And when I got employed by Ghana Atomic Energy Commission, I was moved to the Ghana Space Science and Technology Institute. And there I got to learn about astronomy, which I've always been kind of fascinated by because I knew a lot of constellations and I was always looking into the night sky. And then as I got deeper into the field, I realized that I could merge chemistry with astronomy and that there was a field of study called astrochemistry. I was really excited the first time I heard it, and I strived to know more about it. And so I got a chance to go and do a PhD in astronomy and astrochemistry at the University of Manchester in the UK, where I studied the chemistry of massive stellar objects, which is stars that are 200 times the size of our sun, and in their infancy, when they are being born, what we call new stars. We try to understand how the environment around them are changing with the birth of the star. So that's how I became an astrochemist.
Wow. So it's quite fascinating, but can you tell us a bit about your background as a child? What actually got you into this field that you find yourself in?
As a child, I was always fascinated about science, about the environment. I remember as a child I was mixing paracetamol and iodine, because in my simple thinking as a child, paracetamol was for pain and iodine was for wounds. So if your wound is aching, the best thing is to mix paracetamol with iodine and put it on your wound. And my daddy and mommy always encouraged me. They were not really fussy about me experimenting, mixing their drugs in the backyard, as long as I was not taking it in my mouth. And so that interest always was there. And initially I thought I wanted to be a medical doctor. But as I went into senior high school like this, I realized I was more fascinated with chemistry, with organic chemistry, with dyes and all the long chain chemistry. And that's how my interest in science and chemistry started.
Okay. So how does it feel? I mean, as the first woman to be an astrochemist, like, what's the feeling like?
The feeling is surreal and at the same time kind of a burden.
Okay.
Because I feel the story is when I was doing my PhD, what kept me motivated was that I have 2 young girls. And as a young lady growing up and doing science, my mentors were always my science teachers. You know, my chemistry teachers in senior high school was a man. My mentor in university was also a man. And when I came to my master's too, all the lecturers were men. So I was thinking, so who are the mentors for my girls? Who is going to mentor them? So I couldn't fail. It was difficult, but I couldn't fail because I wanted to be a role model for my girls, and not only for my girls, for all the young ladies who have the aspiration to be, but they don't really often see women in that kind of level, women even teaching them in the field that they are interested in. So that's why I pursued and actually became an astrochemist. So it is a good feeling to have a PhD in astrochemistry, but it's also a mission for me, a duty for me, I think.
Okay, so it's more like a passion.
A passion.
Yes.
Yes, passion, I would say.
what are some of the challenging experiences you've had? I mean, a lady in this field, meeting a lot of guys also in this field. As you said, your mentors have always been men. What are some of the challenges you faced trying to find your way through it all?
Challenges. I think one huge challenge would be the sharp learning curve. Because my field has been chemistry, but astronomy is a very, very broad field that we don't teach in depth in Ghana. So going outside to go and learn astrochemistry, it's astronomy plus chemistry. So astronomy is just a bit of it. So learning the astronomy, learning all the computing that comes with it, the languages that come with it, the softwares that come with it was a huge learning curve for me. It took a lot of hard work, a lot of asking for help, a lot of nights of reading to understand that aspect of the kind of research I was doing to be able to overcome and pass my thesis.
Okay, so I mean, here in Ghana, we are in Ghana, so I'm going to base here in Ghana. As a woman who has made headway in this field and you are actually doing great for yourself, can you tell us some of the experiences you've had and some of the young individuals that you've tried grooming? Have you ever groomed any, and what are some of how has the experience been like?
I will not say I have groomed, but I have met a fair amount of young ladies who have come to visit the radio telescope, the observatory. And I've always made it a point to tell them my story, to encourage them to pursue science, to encourage them in their interest, because not everybody is interested in science. But it takes dedication to still pursue your passion. So I've always wanted to to make that message clear to the young people and the young ladies in particular. And I think I've had some young ladies take my phone numbers, and some have called me afterwards for follow-up talks, for follow-up conversation. And also, when we've had the trainings for students who have finished their BScs and they are maybe doing the natural science and stuff, and we are doing the basic astronomy training for them, some have called me back to give them recommendations to pursue further studies. And I really think that is something I can be proud of if I've made an impact in their life.
Okay. Yes. So is there any initiative or strategy you would like to bring on board to help young individuals to also venture in this field and also excel?
I think for me personally, I always think the interest starts from when they are young.
Okay.
So I've always been basing my form of science communication on children who are in primary school.
Okay.
Like between 8 and 9 and 10 years, when they are very inquisitive, they can ask you all the questions that they have thought of, what they've heard, what is true and not true. So when we have visits here, I'm always asking, what do you know? And what do you want to ask me? Because that's when you can demystify some of the things that we know. That's when you can pique their interest. You can tell them the fun, interesting, weird things that are in space. And these kind of stories pique their interest. And so that interest stays with them. Even if they're not interested in science, they are more sympathetic to the country buying into science. If someone is doing science, they don't find a person boring. They are kind of, I've learned this before, and it's interesting. I went to this place. Have you been there before? They are more sympathetic to others pursuing science, because though STEM is important, not everybody is for STEM. Not everybody is interested in doing STEM. Some like art, some like drawing, but it's all about being sympathetic to somebody's interest also, and not discouraging them. And also, one of the initiatives I've been taking is to bring a more hands-on activity at the observatory during our visits, because we know we have three main types of learners. We have those who learn audially, those who learn visually, and those who learn with particles. So if they come here and you talk to them and you show them all the animations and the videos, they get excited, but somebody goes and they forget because they never tried their hands. And so we are bringing more hands-on activities for the children, at least one activity that they can try with their hands, they can draw, they can paint, they can make, and take it home with them, and that will make the lesson stay with them. Yes.
Okay. So in one way or the other, we are inculcating space science and astronomy in their day-to-day activities in school.
Exactly.
So let's say, talking about starting from the basics, from the kids. So let's say someone is actually interested in computing. How would the person fix space science and astronomy in it?
The surprising thing is that space science and astronomy uses a lot of computing. We need a lot of computing. We write softwares to model our data. We are always programming. We are always creating codes to run our data. So in astronomy, you can't be an astronomer without knowing a computing language. Okay. You have to at least know Python. You have to know how to code to solve the problems that you are facing. A code to know how you can process your data. So you can fit in easily if you are computer literate in astronomy.
In your opinion, in your own opinion, what role does astrochemistry play in addressing societal challenges and issues?
Well, if you ask what astrochemistry does, astrochemistry on its own may not solve a societal problem. But what you learn as you go forward in education is that no one subject stands alone.
Okay.
Astrochemistry starts to merge with astrophysics, and astrochemistry starts to merge with astrobiology. And together they solve a problem. Because if all the astronomy, the different aspects of astronomy come together to look at something, to solve an issue, it is a solution for the society. Now, one of the my mother in the house might not know what my astrochemistry will do for her, but my interest and the interest of my colleagues in understanding how stars are formed is now our urge to come to the engineer and tell him that we want to look further into the star. Can you increase the efficiency of our receivers? And then he will go to a drawing board and design a receiver for us. Now, this receiver never existed in the world because we've been using one type of receiver. But now we want to go further, so we have increased the efficiency of a receiver because of our interest. Then the engineer will do it for us, and now it works. And then he goes to the general public and say, okay, I've developed a new receiver, and you can use it in your mining if you want to scan the earth. Somebody is using it for space, but now you can use it to scan the earth. The miner can now use it to investigate the land and see whether there's gold here and go further. Or the one in the marine will use it to maybe observe the seabed, or somebody in the hospital will use it for a scan. Sure. So what space science does is sometimes people don't see the direct effect in their life, but what we call spin-offs with the research that we do, that the spin-offs from our research affects almost every area of your life. And so you will see that the Wi-Fi that you use on your phone, the cameras that you use on your phone, the internet connection that you use on your phone are all spin-offs from space science research. Yeah. So if I tell you right now that my astrochemistry is affecting my mother at home, probably no, all she's getting the money I get from my salary. Sure. But the spin-offs from that kind of research that has gone through engineering, through computing, have other uses in other areas of science, and that also helps the society. Okay. Yes, that helps.
All right. So, taking your last words, what would be your advice to young ones who are watching, and what are some of the things you would want to tell the viewers concerning Ghana Radio Astronomy Observatory?
So, what I'll tell young people is that if you are interested in pursuing a course or a job or anything you are interested in pursuing, you have to be dedicated. Without dedication and hard work, you will give up. And you must have a reason why you are doing it. You should know your why. Why am I going for this? If your why is not strong enough, you realize that at the end, you give up because maybe the challenges you are meeting your why is not big enough to surmount the challenges. So your why should be solid, and then you should be willing to work hard towards it. Now, Ghana Radio Astronomy Observatory is an amazing instrument that Ghana has now. And most countries will yearn to have it. The money that has been spent to do it is a huge amount. And it's a way for us to stand on par with the international world. So more people should support us. The government should give us more support. They already support us, but we need more. And also, we need more staff, because everything without staff strength, if you have just 2 people here, nothing will work as it should. With more staff, we can always do more and make Ghana proud and put Ghana on the international stage.
We can do more and put Ghana on the international stage. That is it from Madam Naomi, the first female astrochemist in Ghana. Thank you for watching today's segment, and don't forget to like and subscribe.